Hello everyone, welcome to DC Minds. In this video, we are going to learn about another design pattern called Factory Design Pattern. Factory Design Pattern is a creational design pattern. It helps us to create objects without specifying the exact class name. So, Factory Design Pattern is used in case where you have multiple classes and the operation that classes provide are similar in nature, but their end result is different. So behavior of the classes are same, but the result will be different. So here what we'll do, we are going to implement a factory. So there will be a factory method which will allow us to create the object of those classes which are similar in nature, but their behavior will be different when it comes to result. Okay, so here we will not specify the exact class name. Instead we are going to create an interface, and from that interface we'll have multiple child class derived, and their implementation will be hidden from the outside user. So here we are going to hide the creational logic, and just an interface will be exposed to the outside world for various use. Okay, so now let's see a real life application where this factory design pattern might be used to implement that feature. So all of us have used this Microsoft Word document. So in this Microsoft Word document, if you go to this insert tab, and under insert tab we have shape option. Under shapes you can have multiple shapes. Okay, so you can draw a rectangle, you can draw oval, rounded rectangle, and then triangle. So whatever the shape you want, you can just select and draw it. Now I can draw oval, I can draw arrow. So here we have multiple options. So each of these each of these are a shape, and all of these are common in nature, means all of the classes are similar in nature, but their functionality is different, means all of them have some drawing functionality, but its end result are different. So in, instead of so all of these shape can be represented as one class. So this rectangle can be defined as one class, this oval can be defined as another class, and this arrow can be defined as another class. So here when we it comes to drawing this shape, we instead of directly creating the instance of this shape, we can create a common factory method where just user will select a option that I want to draw a rectangle, I want to draw a oval, I want to draw a arrow. So what we'll do, we'll just give the option to the user saying that press 1 to generate create a rectangle, press 2 to create a oval, or some option like this. Basically you will give some option saying that this indicates rectangle, this indicates oval. So here the creation logic is hidden from the user. It is just some option that is given to the user for creating various object. So to implement this kind of behavior, we can use factory design pattern. We'll see how with the coding example. So now let's see a simple factory design pattern which implement that behavior. Okay, so what we have done is we have created a simple interface which has this draw method, and name of this interface is shape, and from this shape we have created various shapes like rectangle and circle, and in each of these shape class like rectangle we have overridden this draw method, and we have added its corresponding functionality. This is just a dummy code. You can add the code according to the need. Okay, so similarly we have created another class which is derived from this shape, and we have added this functionality with respect to drawing a circle, the dummy code, and similarly triangle. So here we have what we have done, we have created three shape class from this shape interface, and then what we are doing, we are creating a factory. So here we have factory class, and this factory class is having a static function called get shape. So what it does, based on the user inputs, so user will say, give various options, like he can say 0, 1, 2. So here what we are telling, if he enters 0, it means he can select rectangle drawing option. For 1 it is circle, and for 2 it is triangle. Okay, so now in the from the main, what we are doing, we are just creating the object using this get shape function, and we are telling the user, we are telling the application saying that I want to draw a rectangle. So in this case what will happen, it will come to this shape function, and it will draw, basically it will create the object of this rectangle, and it will be passed to this shape class. So basically this is a shape is a interface, so it will be pointing to this rectangle class, and then we are creating the object of circle and then triangle, and then we are calling the corresponding draw functionality. So here we are drawing three shapes. So basically what we have done is that instead of directly creating the object of this rectangle, circle, rectangle and triangle, here we are just using this factory method to get the instance and perform the corresponding feature. Okay, so if you run this program, you can see the output like this. So you can see the rectangle is drawn, then circle, then triangle. So you can also implement the same thing for like some of something like this. So what you can do, you can give some option to the user like this. So what you can do, you say user that if he press 0, then he can draw rectangle, if he press 1, then he can draw circle, and he press 2, then he can draw triangle. So now if I run the code, here it will ask me the option that I should choose. So I'll say I want to draw circle, so I'll say 1. So in this case what will happen, the object of circle class will get created, and then circle will be drawn. So you can see the output here, circle is drawn. Now if I say here I want to draw triangle, then I'll say 2, then it will say this triangle is drawn. Okay, so let's see how this code is working. So all that user is known, that just user knows that he has three options that he can enter, and based on his input, what we are doing, we are performing the corresponding operation. So what we are doing, we are getting the choice from the user, and then we are using this factory method. So in this factory method the choice will come, and based on the choice we are creating the object, and then we are calling the draw function. So here all we are doing is just providing a simple interface for creating the various object and performing the corresponding functionality. So what we are doing, we are hiding the creation logic over here, and we are just giving the interface to the user. Okay, so this is how factory method is used, or factory design pattern is used to hide the creation logic and providing a simple interface for creating the objects of different class, which are similar in nature but their end results are different. Okay, so now let's see another real-time use case of this pattern. So now suppose you are working in a company, which company develops a device which track the satellite signals, and then it converts that satellite signal, that is analog signal, into digital signal that is readable by human. So all those signal that is converted into digital can be text message, or it can be binary message, or it can be some encrypted message. Now the converted signal has to be processed and displayed to the user, means displayed to the user saying that what kind of information it is. So here we have various kind of message. So all the messages are similar in nature, and their behavior will be different when it comes to end result. So all these messages will have some common processing method, but their processing logic will be different. So here, instead of directly creating the object of each this a message class, means you can have message class, class for this text message, class for this encrypted message, and class for binary message. So here, when you want to suppose you have received saying that it is a binary message, so instead of directly creating the object of binary message class and calling their corresponding functionality to process the message, what you can do, you can implement a factory method for this message class, where you will give a interface where you will call a common function that will be processing message, and then based on the input of the user, based on the type of the text message, you call the corresponding class functionality. First you will create a corresponding class object, and then you call the processing message of that. So in this kind of situation you can use factory design pattern, where all of these messages are common in nature, but the way it is processed is different. Okay, so now let's see another use case of factory design pattern. So suppose you are working in a healthcare department or healthcare company which develops various medical application, and though that application has so many algorithm, it has algorithm to detect cancer. So this cancer detection will happen based on the scan that is taken. So there will be some images, and from the image you want to detect whether the person has cancer or not. So another algorithm, it has a tissue damage detection. So suppose the person has made an accident, and from the scan you want to check whether there is a some damage in tissue. For that also there is a algorithm. Similar to that, we have some calcium deposition algorithm detection, and then we have metal detection. So you just want to check whether the person has some implants, like when you go before you go for a scan, you have to ensure that the person is not wearing some metal in his body to take the scan. So for that also you can have this metal detection algorithm. So now if you see, all these algorithms are similar in nature, but their way of processing is different. Their functionality is different, but they are similar in nature. So for each of these algorithm we will have a separate classes. So here, whenever a scan is taken and based on the user input, like the user will say I want to check whether particular scan is containing some cancer or not. So in that case, instead of directly creating the instance of this algorithm, what we can do, we can define a factory method which will create the object based on the user selection and then perform the corresponding algorithm. Basically it will call the corresponding algorithm function, and it perform the required operation. So here we are going to hide the processing logic or the algorithm logic uh, from the user by creating a common interface, that is factory method, and that will be given to the user, and the internal creation logic will be hidden from the end user. For this purpose also you can use the factory design pattern to hide the creation logic or implementation details by just creating a interface, and that has a function called factory function. Okay, so this is all about factory design pattern. So in next video we are going to learn about another design pattern called builder design pattern. Thanks for watching. If you like this video, please subscribe to my channel and hit the like button. If you have any query, please comment it.